Hi everyone, we're going to analyze a graph of a rational function. This is number 12. We'll just call this one g of x. So we'll just call this g of x. And we have x over x squared minus 4, which is x over x plus 2, x minus 2. I went ahead and factored it. This is your p of x. This is your q of x. The degree in the numerator is 1, and the degree in the denominator is 2. Since the degree in the numerator is smaller than the degree in the denominator, we're going to look at step 6. It means we have a horizontal asymptote. That means we don't have an oblique, and our horizontal asymptote is y equals 0. Our domain, it's already in reduced terms, so we don't have to do that. There's nothing we can cross out, factors. Our domain, therefore, is going to be x, such that x cannot be plus or minus 2. That also means we have a vertical asymptote at x equals plus and minus 2. We don't have a hole because it's already in reduced terms and we don't cross anything out. And basically, we're going to first find the intercepts, and the x-intercept, we set the numerator, p of x, to 0. So 0 equals x, because that's my numerator. So that's your x-intercept. And your y-intercept is you plug in 0. So you get 0 over 0 squared minus 4, which is 0 over 4, which is 0, 0. Let's test for symmetry. We're going to test g of negative x. And everywhere there's x, put negative x. G equals negative x over x squared minus 4. This is negative g of x. So this is an odd function. This means it is symmetric. The graph is symmetric to the origin. Okay. We got to see if the graph intersects our horizontal asymptote. Our horizontal asymptote was y equals 0, so you set 0 equals x over x squared minus 4, and we get x equals 0. When you plug in 0 again, you get 0 over negative 4, so it intersects at the origin, so it does cross the horizontal asymptote, so there is an intersection. Okay, and you can go ahead and graph using your calculator. And I'm going to go ahead and pick intervals. I pick negative infinity to negative 2, and then 2 to 0. Then 0 to 2, this is negative 2, sorry, and then 2 to infinity. I'm picking these intervals because I have a vertical asymptote at negative 2 and 2, and I have a x-intercept at 0. And I want to know how the graph behaves on the left and the right, and then in between what's going on with the x-intercept, if it's above the graph or below the graph, above or below the x-axis. I'm going to pick points. I'll pick negative 3, so you choose some points or numbers. We're going to choose numbers. here. I'm going to pick -3, -1, 1, and 3, and then evaluate G. So G of -3, G of -1, and G of 1, and G of 3. So you plug in -3, you get -3/5. -1, you get 1/3. 1, you get -1/3. And 3, we're back at 3/5. Okay, and let's look at the location on the graph. So this is going to be below the x-axis. This is positive, so this is above, below the x-axis, and above. You're going to write your points down. That means your x and your y. Get -3, -3/5, -1, (1/3), 1, -1/3, and 3, (3/5). And then we can graph this. And I'm going to draw my vertical asymptotes, which are x equals -2, so x equals -2, and x equals 2. It does cross. Here's my x-intercept, and from my intervals, I know that from -2 to 0, it's above the graph, and from 0 to 2, it's below the graph. I know this is also symmetric to the origin, and then I'm going to go ahead and plot my 3 and 3/5, and my -3 and -3/5. And we have a horizontal asymptote. That's where it's crossing the horizontal right here at y equals 0. So I'm going to graph this here, and I graph this here. So this graph was symmetric to the origin. Oh, this point here was 3, (3/5), and this one was -3, (3/5). And of course this was 0, 0, and you can plug in the other points. We had -1 and 1/3, so this actually should have come down a little bit more. But anyway, there's your graph. Thank you. Have a nice day. Bye-bye.